Hi, today's notes are on 6.6a, solving exponential equations using logarithms. And we're doing this since exponential and logarithmic functions are inverses of each other, right? So inverse operations. So we're going to focus on just exponential equations today, right? So given an exponential function where the variable is in the exponent, notice all of them, and I can have multiple variables, which we have not had so far, okay? So there are two methods to solve exponential equations. And the first method is to make the bases the same. So rewrite the bases to be the same. And then set the exponents equal to each other. Uh-oh, out of space there, sorry. And so let me give you a quick example. We'll talk about these two in a moment. But for example, like if I have 5 to the x, and I notice that my bases right now are 5 and 25, well, I know 25 can be rewritten to have a base of 5. Like this is our goal here. And if that's the case, then I can rewrite 25 as 5 squared. And at this point, if I know the bases are the same in an equation where the two sides are the same, then the exponents must also be the same. So I can sort of cancel out the base of 5. And I'm just writing this the first time, okay, on both sides. And we know then that x must equal to 2. Okay. So for example, 2, if the same base is still 5, right, that means I can cross out the 5s. And then I will have 2x equals 5x minus 8. And your goal is to get the x's on the same side. And this now becomes an algebra 1 problem, right? We want the x's on the left and the numbers on the right. I try to be consistent so that we just don't have to worry about which way do we go. So I will always consistently move the x's to the left. So I have a positive 5x, which cancels with a negative 5x. 2 minus 3. If you struggle with signs, this is where you don't have x's on your calculator, but you can do, 2 minus 5. You can do this. That gives us negative 3. Just be sure to throw the x back in. Okay? Equals to negative 8. Don't panic because the numbers don't come out nicely. I'm going to divide by negative 3. The negatives cancel out, and we get x equals 8 over 3. Now, let's be sure that this works. Okay, so let's plug these in. 2 times 8 over 3. Okay, and then I can do 5 times 8 over 3 minus 8. And notice they're the same, so our equation is balanced. So you can always do this and plug your x into the original equation to check if your solution is correct. Okay. What if it's not as simple as that? So like in example 3, you'll notice that I have a base of 3 and a base of 9. Well, our goal is to change the bigger base. Okay. We don't want to make this 9. If you do 3 squared, that means you have changed this number without changing the right side. When I change the 9, I'm rewriting. Okay, so I'm not changing it. I'm going to make my base a goal of 3. We always want the goal base to be smaller than one of the bases at least. So let me show you what I mean. 9 can be rewritten as 3 squared. So do you see how like technically the right side has not changed? I still have a 9 here and I still have a 9 here. And the only thing that's different is that I rewrote the bases to be the same. If you did it differently, okay, so let's say pretend what you did was you changed this to be 3 squared on the left side to match 9 to x plus 4, if I'm looking at this problem, this looks great. Okay, it is a 9 and a 9, a base of 9. However, if you take a look, we've added something to the left side and changed this number, whereas over here we have not changed the right side. Okay. Once we have these, my base of 3 gets canceled out. And the really important thing is that you need to distribute the exponent of 2 to both of the other exponents. So I'll have x plus 7 equals 4x. Well, let's write it as one more step, just this one time. So I have 2 parentheses, 2x plus 4, right? And we can just change the spot of the parentheses, and we have to distribute to both. So I have x plus 7 equals to 4x plus 8. I'm going to subtract 4x on both sides. That gives me negative 3x plus 7 equals 8. And I'm going to subtract 7 on both sides, which gives me negative 3x equals 1. Okay. Final step, divide by negative 3, and we get x equals 1 over negative 3. Once again, you can plug it in, and when I plug this in, notice I don't really care if it's a decimal or not, so you can literally just go 1 over negative 3 plus 7, and then you can go 2 parentheses negative, 1 over negative 3, close parentheses, plus 4. And, oh, uh-oh, something went wrong. Well, that's awkward. Hang on, did I mess up somewhere? X plus 7, right? So now I have a problem because these don't actually match. They look close, but they're not quite. So what did I do incorrectly? X plus 7 equals to 4x plus 8. I subtracted, so that's negative 3. I subtracted, that's 1. Divided by negative 3. Now the question is, did I type this in wrong? Let's do this. Ready? 1 divided by negative 3 plus 7. Okay, and then 2 parentheses, 1 divided by negative 3 plus 4. And those are still not the same. Hold up. Okay, guys, made a stupid, foolish mistake. I forgot that the bases are not the same, right? So I can't just plug it into the exponent. I have to do 3 parentheses, 1 divided by negative 3 plus 7, and then 9 to the power of 2 parentheses negative 1 over 3, or 1 over negative 3 plus 4. Ooh, 9 to the power of, oh goodness, what is going on? Oh, here, I've got an exponent. There we go. I'm so sorry about that. All our work was correct, but just had to prove my point. So, important mistake that I made. Don't just plug into the exponents if the bases are different, right? I could do that here, but when you plug it back in, you want to make sure you take the entire equation. Okay, so let's keep going. Before we do the second row, example 4 and 5, let's talk about negative and fraction exponents. We'll do a quick reminder. Remember that if you have, say, like 5 to the negative 2, another way of writing it is 1 over 5 squared. Okay. And so this is the same, like 5 squared looks like 25, but this becomes 1 over 25 because there's a negative. Fraction exponents. Let's say we have, let's go 16 to the 1/2 power. On your calculator, that's going to look like 16 to the power of 1/2. Okay, so just a reminder that the 1/2 needs to be an exponent. That's going to be a square root. So the square root of 16 is 4. So let's take a moment and notice that we have 5 and 25, and so we want to change the bigger number. Okay, we don't want it to be 25. We want our base to be 5, because I know that 5 squared is 25. Okay, so notice nothing has changed. It's still the same. The left side, if I want the base to be 5, well, there is a fraction now, right? And so if we want to come and look at this one, the number got smaller, this one became a fraction. So we want it to be to the -1 power. And then I'll copy down my exponent. Okay, so this is the hardest part, where you're figuring out what base needs to happen. And my hint is you always look at the smaller number regardless of what the, like if it's a fraction or not. Okay, that's the first place to start. So I have -1 parentheses 3x minus 2 equals to 2 times x. So that'll be, if I distribute -3x plus 2, be careful of that negative times a negative, equals to 2x. Okay, this is an example where we don't necessarily want the x's on the left side, because if I move them all here, I have a 0. I'll show you that though, just because I think some of you guys might make this happen on the day of the test or quiz. So I'll have -5x plus 2 equal to 0. And then I can subtract 2, right? So -5x equals to -2. And then we get x equals 2 over 5, because I'm going to divide by -5. And the negatives cross out. Sorry, these boxes are a little smaller than I expected. Okay, this last one. We think the base might be 4. The smaller number is 4. However, 4 squared is too big for 8. Okay, so that means 4 doesn't actually work. So we need to be smaller. So go smaller here. So if a base that you choose doesn't work, you need to think of a smaller number. So smaller than 4, it can only be 2. Okay, so if it's 2, then I can rewrite it as 2 squared for 4 and 2 to the 3rd power for 8. And then I'll copy down 2x minus 1 and x plus 2. I'm going to distribute these here just to save me some space. I can cross the 2's out because the bases are the same. 2 times 2x is 4x. 2 times -1 is -2. 3 times x is 3x. And 3 times 2 is 6. I'm going to subtract 3. That'll be 1x minus 2 equal to 6. I will add 2. We get 1x equals to 8. Okay, notice I just took the 1 and I made it part of my box. Okay, let's keep going. So at this point, this is for you to practice. Okay, so notice 4 and 16. I'll help you with the bases. My hint to you as we get closer, number 6, please make sure your base is not 4, because 4 squared is too small and 4 to the 3rd power is too big. These are the ones where you have to think of a different number, even smaller. Okay, so pause the video here and try your problems. I'll post answers shortly, but I won't show my work. When I come back, I am going to check to make sure that you filled in these work, or all the work in here. So please don't just copy this down. Actually try it. That's part of your classwork today. I did write this one out just in case you were struggling a little. So if you notice that 3 to the -3 becomes 1 over 27, and then 3 squared is 9. Okay. So then the question is, what if the bases cannot be the same though? So all of the first page was talking about, like, let's make the bases the same. But what if I give you something like this, where we have a base of 3 and a base of 5, which will never ever be the same? Okay. Well, then method 2 is to take the log base something of each side. Okay, and here's the thing, you want to pick the side with an exponent, or with a variable. Okay, to cancel out one base. And get x by itself. So do you see how here it wouldn't be very helpful to cancel out this base of 5, right? Because there is no x, but I do want to cancel out that 3. And so let's remember that exponents with base b, in our case 3, cancel out with logarithms. with base b. Okay. So they undo each other. So let's take a look here and see what we can do. That means we can cancel out with a log base 3. Okay. And what we have left is x plus 3 equals log base 3 of 5. And to get x by itself, we're going to subtract 3. And the only problem now is that we have a log base 3 to put into our calculator. And that's where we need our change of base formula. So this, we did learn this a while back, but let's just make sure we have it. Our change of base formula says that if I have log base b of a, we can rewrite that to log base c, so a new base of a over log base c of b. Now notice, a goes on top for argument, b is our base, and it goes on the bottom. Well, let's make it even simpler. On our calculator, we could just hit log of a over log of b. And if you wanted to, since my base can be anything, that means it could also be a base of LE, which means I could have ln of a over ln of b. So these are the two that we're going to use on our calculator. Okay, and it doesn't matter which one you use. I just tend to use log because that's what I have here all the time. So on our calculator, we're going to hit log of 5, and the base always goes on the bottom, divided by log of 3, minus 3. So how will that look? We're going to have log of 5 divided by log of 3. I like to close my parentheses and then subtract 3. Okay? So my final answer here is x equals, I didn't tell you what to round to. Let's round to 4 decimal values. Oops. Decimal values. Okay, so that'll be 1.5350. And so let's just do another one. This one will be fairly similar. We want to cancel out the 2, so an exponent with base 2 cancels with a log base 2. So that gives me 3x plus 1 equals log base 2 of 7. I'm going to subtract 1 on both sides. I'm going to write it super small here. Then I'll have 3x equals log base 2 of 7, close parentheses with the 1 on the outside, with a minus 1, and then divide by 3. Divide by 3. Okay, so here's where it gets a little messy. We know we're going to have a log of 7 divided by log of 2, right? That's this part right here. We're going to subtract 1 to everything and then divide everything by 3. So how will this look on your calculator? We're going to do log 7, close parentheses, divided by log 2. Hit enter. I don't need to see the work for this anymore. We're going to subtract 1 first, and then divide by 3. Okay. That's 6 decimals, 0.6025. Okay. So right here, let's just take a note. To get rid of an exponent base 3, we are going to log base 3, or take the log base 3 of both sides. And this time our answers are going to be a decimal because the bases cannot be the same, which means we're working with decimals here. Okay. The thing is that we want to get rid of numbers one by one. So there's this extra 12 in front, for example 8. So we're going to divide by 12 first. And we get e to the 1 minus x power equals to 500 over 12. Okay, this one you want to be really careful of. When you subtract 1 on both sides, there is still a negative x left over. And that's something that a lot of students often lose. So then we divide by -1. I do want you to write out what x is equal to. Like, what are we typing into the calculator? This one, we don't need to do anything more, right? ln is just a number, so we don't have to do anything fancy. And we can just go straight into our calculator, which is ln of 500 divided by 12, close my parentheses, and then I'll subtract 1 and divide by -1. So -2.7297, because the number after that is a 0, so nothing changes. Okay, we're really close to being done. How can we now just make it a tiny bit more complicated? Well, the only thing I can do is add more numbers to solve, right? So if you take a look, now I have this -14, but in Algebra 1, we learned that if we want to get rid of a -14, we just add 14. And then I have 3e to the x power equals to 25. Okay, well, I want e to the x by itself, so I'm going to divide by 3. And I'll have e to the x equals to 25 over 3. It's a decimal, so I'm leaving it like this. Get rid of e by taking ln of both sides. And we get x equals ln of 25 over 3, which is 2.1203. Okay, do you see that there's a 6 there? It's the 5th number, so that rounds up. Okay, we are at the point where you are going to pause the video, do the last 3 problems as you tries. Notice that they all match, so example 6, example 2, and then maybe this is the last one. I'll post the video shortly. Okay, please show your work and don't just bank on my answer. Okay, so when you guys try number 3, you're going to realize that you're going to get a non-real answer. Because what happens is, we're going to go -8, -8. And then we have -3, 5 to 3x minus 2 equals to 4. Oh, sorry, 24. And if I divide 24 by -3, I get 5 to the 3x minus 2 equals to -8. Okay, let's keep going. We'll take the log base 5 of both sides. And we'll realize that you can't take the log of a negative number. So let's change this problem to make it doable. And I'm going to change all of these negatives to positives. And now you can keep going. This is your final answer to check. Okay, I'll be back to answer any questions you might have.